Good morning, students. Today we are going to go further on our stoichiometry. Today we are looking at how to convert from mass to particles or molecules using Avogadro's number. Our Avogadro's number is a constant term, which is 6.02 times 10 to 23rd power of particles or molecules or atoms. The standard we are going to address today is Standard 3 of Chemistry, Georgia Standard of Excellence, which is SC3D. Obtain, evaluate, and communicate information about how the law of conservation of matter is used to determine chemical composition in compounds and chemical reactions. Use mathematics and computational thinking to identify and solve different types of reaction, mass, moles, and molecules relationships. Then molar volumes of gases. Today's lesson learning target is I can convert mass to particles and vice versa from a balanced chemical equation. An assessment will be your ability to convert mass of a substance to particles in a balanced equation. Right, let's look at the first example, mass to particles or molecules. How many oxygen molecules are present in 0.470 grams of oxygen gas? Remember, our steps is 0.70 grams of oxygen. Whatever you are given, remember, comes first. Alright? So you make a T-chart. Okay. The unit you have here is grams per oxygen. That is the first thing to do. Write grams per oxygen. Anytime you see grams, what comes to your mind is periodic table. That's where you get your atomic mass from. Now, oxygen is 16.0. But remember, oxygen is diatomic, so it has to be times 2 to get 32 grams. And this is 1 mole of oxygen. So 1 mole of oxygen comes to the top. Alright? So, you make a T-chart. The grams of oxygen will cross grams of oxygen. That is the essence of your unit. If you don't put a unit, you might not know what to put at the bottom. So you have mole of oxygen here. The same way you did this, just write mole of oxygen. Alright? And this is 1 mole. Now remember, our Avogadro's number is 1 mole of any substance of oxygen contains 6.02 times 10 to 23rd molecules or particles or atoms. So if 1 mole of oxygen contains that means you write 6.02 times 10 to 23rd particles here. So that mole of oxygen will cross mole of oxygen. So what you have left is just particles, which means you multiply 0.470 times 1 times 6.02 times 10 to 23rd power. Write your answer down, then divide by 32. Alright? So let's go back to our PowerPoint. So we have grams cancelled in grams, just like we did on the board. Mole of oxygen cancel mole of oxygen. And then when you multiply the top, all this top divided by the bottom, you will get 8.84 times 10 to 21 power of molecules of oxygen. Right? Now I want to take you to step by step. You can choose any one you like. If you want to do the 3 steps form, that's fine. Double step at a straight, that's fine. If you want to do it 1 step at a time, that's okay with me. So how many molecules of oxygen are present in these grams of oxygen? Step 1, convert this mass to moles. So this is what you do. You divide this 0.47 grams of oxygen multiplied by 1 mole over 32 grams. You will get, of course, the grams of oxygen cancel the grams of oxygen. So you have 0.0147 moles of oxygen. So you are going to use this answer here as your step 2. So you are converting these moles to your molecules. So it's like multiplying the moles by the molecules. Remember, this is Avogadro's law, Avogadro's number, which is a constant. So you multiply 0.0147 moles of oxygen by 6.02 times 10 to 23rd power molecules of oxygen. You know that moles of oxygen will cancel mole of oxygen. So what we are left with, the unit you left behind is molecules of oxygen. And that is what the question wants us to find. So you multiply the top, divide by 1, we see the same thing. So the answer is 8.84 times 10 to 21 molecules of oxygen. What is the mass grams of 2.01 times 10 to 23rd atoms of sulfur? The same way we did the first one, what we are given comes first. This is what we are given. So I'm going to combine the two in this table. So what we are given comes first. 2.01 times 10 to 22nd power atoms of sulfur. Remember, you write atoms of sulfur at the bottom so that you know when you see atoms, you know it's going to be Avogadro's number. So that the atoms will cancel the atoms. 1 mole, of course, will be at the top. And then, because we are converting to mass, this is the mass of substance you are looking for. Anything you are looking for will always be at the top. We're looking for atoms of sulfur. You are looking for the grams of sulfur. You are given these molecules or atoms. So that means your sulfur will always be at the top. And then the molar mass of sulfur is 32.07 grams. So that your moles of sulfur will cancel the mole of sulfur. So what you have left is 2.01 times 10 to 22nd power times 1 multiplied by 32.07 grams of sulfur divided by 6.02 times 10 to 23rd molecules of sulfur. Then we cancel out. Then you multiply the top, divide by the bottom, we get 1.07 grams. Right, let's do this. Pause the video and practice these problems. How many molecules are there in 450 grams of sodium sulfate? And how many grams are there in 2.3 times 10 to 20th power atoms of silver? The answer for the first one is 1.9. Make sure you pause the video before you continue so that you can work it out before you see the answer. The answer for the second one is 0.04 grams of silver. Now, this is your ticket at the door. Make sure you complete this assignment and send it to my Google Classroom. You see the classroom assignment in your Google Classroom. Click on that and then turn in the assignment after you have completed it. And click turn in when you are done. That is the end for today's lesson. Good luck.